Okay, what are interior angles of polygons, and what is a regular polygon? So let's talk about this concept and kind of what we can do mathematically with it. So if you have, we'll start with the most basic polygon, which is a triangle. Hopefully you know what a polygon is. Hopefully you studied triangles a little bit already, and so this isn't new to you. But the interior angles are these angles on the inside, and if you're getting ready to study polygons, you've already probably talked about the fact that a triangle, when you add up the three angles on the inside, it's 180 degrees, and there's lots of cool proofs on why that is. This particular triangle is equilateral, and I've marked all the angles as equal. Equilateral means all the sides are the same length. And so in this case, each angle is 60 degrees because it has to add up to 180. They're all the same. And so that would be the interior angles of a polygon. Now, just really quickly, we're not going to talk about it in this video. I'll do that in the next video. But this angle out here, if we kind of extend each line out, those are exterior angles. It makes kind of a pinwheel. And together, those are also 180. So like the exteriors for this would be 120 if the interior is 60, because it has to add up to 180 degrees. It makes a straight line. Even though I can't draw a straight line, it has to make a straight line. So there you have it. So that's a triangle, and its interior always, no matter what the triangle is 180, no matter what size. And hopefully you've already talked about that, like say in another class. So what we can do then is let's talk about maybe the next shape, which would be a square or a rectangle or a quadrilateral. Well, what's kind of cool about this is if you pick a vertex of that shape, I'm going to pick that one, for instance, and I draw in the diagonal, it makes two triangles. So this triangle has a sum of 180, and this triangle has a sum of 180. So together, the interior angles, if you add all of them up, so you would have 360 degrees. Okay. I've kind of skipped over the whole regular part. All the shapes that I've done so far are considered regular polygons. Regular means all the sides and all the angles are the same. So this is a regular polygon, a square, because all the sides and angles are 90 degrees and all the sides are the same length. Okay, so that's the definition of regular. So with that, we could find every angle. So let's go to a shape that's maybe not as obvious, and that's a pentagon, the next one up. So here's a regular pentagon. All the sides and angles are the same. And what you'll notice about it is if you pick a vertex and draw in all the diagonals, which there'll be two diagonals, you create three triangles. And those triangles each have a sum of 180. So we know that about triangles. And there's three of them. So I know that a pentagon is 3 times 180 degrees. Or all the angles inside a pentagon are 540 degrees. Okay, so that's the sum of the interior. So if you add up, and I'll do it with a different color. Sorry for the clunking on my board there. But if you add up all of these angles here, you'd get a total of 540 degrees for all the interior angles. So let's move it up. Let's skip up to, let's see, my eyes aren't really good, so I'll just have to count them. We got we got 1, 2, 3, 4, 5, 6, 7, 8. This is a 9-sided, a nonagon. 9-sided polygon. You can call it a 9-gon or nonagon. we'll just call it Nonagon for 9-sided polygon. And this one's regular, all the angles are equal. And so what's the sum of all the angles inside of that thing? Okay, well, the sum of a Nonagon, if you add up all of these angles, again, we can split this into triangles. So pick a vertex. I'm going to pick, well, let's pick one over here, doesn't matter where, and draw in all of your diagonals. So there's a triangle, there's a triangle, there's a triangle, there's a triangle, and there's a triangle, and there's a triangle. Well, notice there are 7 triangles. If you count these out, 3, 4, 5, 6, 7. So there are 7 180-degree triangles, which if you multiply 7 times 180, you get 1260 degrees. So if you add those all up. So what's kind of nice is you could divide that then by 9. So 1260 divided by 9 is 140 degrees. So I know every single one of these blue angles is 140 degrees. Notice the pattern we're coming up with. 9-sided polygon has 7 triangles that go to 180 degrees. Let's go back to the Pentagon. 5 sides gives us 3 triangles at 180 degrees. So we're starting to build a formula for this. So if we let n be the number of sides of a polygon, we know that n minus 2 times 180 is the sum of the interior sides of a polygon. And back to these blue angles here, you know, this is a regular polygon, all the angles are the same. Well, if we take that 540 that we came up with a pentagon, divide that by the number of sides, we'd get, I think that's 108. I'll just double check. Yeah, so it's 108 degrees. Make sure my memory is correct. And so each one of these angles here is 108 degrees on a regular pentagon. Okay? So try this on another shape. See if you can find the sum of the interiors. So here we go. This is a hexagon, I do believe. Yeah, there's a hexagon. So see if you can find it. What is the sum of the interiors, and what would each angle be? I'm going to go ahead and stop the video and do it. So I think here there are 6 sides. Well, I know that there are 6 sides. If you follow the formula, n minus 2 times 180, we know that it's 6 minus 2 times 180, which is 4 times 180, which would be 720. Again, if you don't have that formula memorized, it's okay. At least have the visualization that, oh, if you divide this up into, there's 4 triangles, that would all add up to 180, so 720 is where you come up with that. Then divide that by the number of angles we have, divided by 6, gives us the total degrees in each one, which is, sorry, I have to write down here because I'm out of room, 120 degrees. So every single angle in this thing is 120 degrees. All the way around, giving you 720 total. So last one, and then I'll call it quits. So we'll do kind of a crazy one. So try this, give this one a shot, and then I'll just splash the answer here in about 2 or 3 seconds. Alright, so this is a 12-gon, probably considered a dodecahedron. You might double check that I'm correct on that. I think decagon is a 10-sided polygon. Dodecahedron, I'm pretty sure, is 12-sided. And so 12-sided, just really quickly, 12 minus 2 times 180. So 10 times 180, so 1800 is the sum of the interiors. 1800 divided by 12 is 150 degrees. And so every single one of these angles in this regular dodecahedron is 150 degrees. So hopefully this helps you understand the interior angles of a polygon. The next video I do will be the exterior angles of a polygon, just so you can see the relationship between the two, because there's some really cool stuff that we can do with exterior angles and knowing the interior and exterior angle of a polygon. So thanks for listening, and I hope this helped.